everyone. Today we're going to start chapter 2, which is all about chemistry and measurements. So in chemistry, we make measurements all the time. We're usually measuring things such as volume or length or mass or temperature and sometimes time. And down below you can see in the picture there are two people walking, and we could make a bunch of measurements here. We could measure the height of each person. We could measure the weight or mass of each person, or maybe their bags. We could also measure the temperature of the air around them and maybe the distance that they're walking. So you'll notice there are different units for each type of measurement. So for instance, this person's height is 1.7 meters or 65 inches. For temperature, we could measure that in degrees Celsius or degrees Fahrenheit. It kind of depends on where you are in the world. Now, scientists needed a uniform system to make measurements, and they decided to use the metric system. So the metric system is used around most of the world, minus a couple of countries, including the US. And they ended up calling they ended up modifying the metric system slightly. And they ended up calling that system the International System of Units. So this is a worldwide standard for scientists. Now, the International System of Units, abbreviated SI, is an official system of measurement used throughout the world for units of length, volume, mass, temperature, and time. Now, you might be wondering why the abbreviation is SI instead of IS. That has to do with the fact that typically we refer to the International System of Units in French, so it ends up as the System International, so it's SI. All right, so again, most of the world uses the metric system except for the United States, Myanmar, and Liberia. So in the US, we use what's called the English system, so we use pounds, feet, ounces, etc. And this has caused some problems in the past. So for instance, NASA was trying to send a, something called the Mars Climate Orbiter to Mars. And it cost $125 million to build it. And they were going to study, for instance, the atmosphere on Mars and any surface changes, etc. And this was back in the 90s, but somebody didn't use the correct set of units. They were using feet instead of meters, and the orbiter ended up crashing. So, we need a set system of units that scientists use, or else things can fall apart, and it's a $125 million mistake. All right, so let's talk about the metric system versus the SI system. They are very similar, but there's just some slight modifications. So for instance, if we're measuring volume, we're going to use either liters or cubic meters. And in particular, the SI system uses cubic meters. Although, to be honest, when we're in lab, we tend to use liters. It's just easier. And then in length, we use the meter for both the metric system and the SI system, so that's the same. For mass, the metric system uses the gram, and the SI system uses kilograms, although those two are very closely related, so it's not a big deal if you use grams instead of kilograms. And then in temperature, we use degrees Celsius in the metric system and something called Kelvin in the SI system. And we'll talk about different temperature scales in a second. Speaking of seconds, for time, we use the second for both the metric system and the SI system. All right, so some of these might be familiar to you and some of them might be unfamiliar. I know here in the US we don't use grams to measure mass, we use pounds. We also use feet instead of meters, or we use yards maybe. We also use Fahrenheit instead of Celsius or Kelvin. So we'll do some labs that involve different measurements and we'll get more familiar with these different units. All right, so again, volume, we can use the liter or cubic meter. We can also use milliliters if we have a smaller amount. So volume is the space occupied by a substance. And typically in chemistry labs, we're measuring the volume of liquids. And one way to do that is to use something called a graduated cylinder. So this is a cylinder with graduation marks on it. Now the SI unit we said earlier was in cubic meters, but typically in lab we will measure liquids and their volumes in liters or milliliters. Now if you're used to the US system or the English system, you might measure something in quarts, for instance. So 1 quart is equal to 946 milliliters. Now we can also convert quarts to liters. So over here we have that 1.06 quarts is equal to 1 liter. So they're sort of similar, they're just offset a little bit. And then later on we're going to talk about prefixes. So prefixes will increase or decrease the size of a unit. So for instance, there are 1,000 milliliters in 1 liter. So a milliliter is a lot smaller than a liter. Now for length, we use the meter, or if we're measuring something smaller, we might use the centimeter. And if you're used to measuring things in terms of feet or yards, a yardstick is a little bit shorter than a meter stick. So you'll notice down below there's this piece that's missing here. And you'll also notice that 1 inch is equal to 2.54 centimeters. So we can use that as a conversion factor. So later on we'll learn how to convert between units. So 1 meter is equal to 1.09 yards. And then we also saw that 2.54 centimeters is equal to 1 inch. And then there are 100 centimeters for every meter. So the centimeter is a little bit smaller than the meter, or quite a bit smaller. Now for mass, we use grams or kilograms, and the kilogram is the SI unit for mass. And the kilogram is typically used for larger masses. Now in chemistry, for what we typically do in lab, we're going to use the gram or even milligrams, which are smaller than a gram. We're usually not measuring that much. So in the US, we're used to the pound when we're measuring mass or weight. So 1 pound is equal to 454 grams. Or if you want to think about it in terms of kilograms, for every 1 kilogram, there are 2.2 pounds. So for instance, If you are, let's say, traveling in Europe, you might need to convert your weight to kilograms, so you could do that using this equality. Now, in lab, the way that we measure mass is with a balance. And so a balance has this little tray that your object sits on. And sometimes you might use what's called a weigh boat, especially if you have a powdery substance that you're weighing. And down below, there's always a 0 button or a tare button. And that button is going to set the mass to 0. So for instance, if you want to get the true mass of this nickel, you might set the weight to 0 first before placing the nickel on there. And then once everything is set to 0, you can put your nickel on the balance, and that will give you an accurate mass for the nickel. So this nickel weighs 5.01 grams. All right, and now temperature. So again, temperature has many different scales. The two that we're going to use most often in chemistry are Celsius and Kelvin. So Celsius is the metric unit, and Kelvin is the SI unit. So water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. And you might be used to the Fahrenheit or Celsius scales depending on where you grew up. The Kelvin scale is a lesser known scale. So the Kelvin scale begins at the lowest possible temperature, 0 Kelvin. So that means that the Kelvin scale is always positive. And that can be really useful for certain calculations. So at the very end of the quarter, we're going to go over gas laws, and we're going to learn all about gases and their properties. And when we're doing calculations with gases, we have to use Kelvin, and we'll see why later on. So scientists learned that the coldest temperature possible is negative 273 degrees Celsius. Now on the Kelvin scale, again, this is 0 Kelvin, or what we also refer to this as is absolute zero. Now the Kelvin scale has units called kelvins, super easy to remember. And we abbreviate that with a capital K. And we actually don't put a degree symbol in front of K to represent temperature. So for instance, we would say degrees Fahrenheit, degrees Celsius, but for Kelvin, we just say Kelvin. And again, this is a positive scale, so there are no negative temperatures. And what's really handy is that Kelvin, or the unit size for Kelvin, is the same as Celsius. So 1 Kelvin is equal to 1 degree Celsius. So let's compare these three different temperature scales. So on the right-hand side, we have a figure of Fahrenheit, Celsius, and Kelvin thermometers. So again, earlier we said that the freezing point of water is 32 degrees Fahrenheit or 0 degrees Celsius. In Kelvin, that's 273 Kelvin. And then if we look at the boiling point of water, in Fahrenheit, that's 212 degrees. In Celsius, it's 100 degrees Celsius. And in Kelvin, it's 373. So one thing to notice is if we compare the boiling point of water to the freezing point of water for these three different scales, There are 180 degrees Fahrenheit in between the freezing point and the boiling point, but there are only 100 degrees Celsius and 100 kelvins in between those 2 points. So again, 1 degree Celsius is equal to 1 Kelvin. But Fahrenheit is the tricky one. So Fahrenheit is kind of doing its own thing. So now, how do we actually convert between Fahrenheit, Celsius, and Kelvin? So to convert between Celsius and Fahrenheit, we need to adjust for the size of those degrees, because remember, there are 180 Fahrenheit degrees in between the freezing and boiling points of water, but there are only 100 degrees Celsius between the freezing and boiling points. So 100 degrees Celsius for every 180 degrees Fahrenheit. So what we'll do is we'll take the ratio of those two scales. So we're going to divide 180 Fahrenheit degrees by 100 degrees Celsius, and that gives us a ratio of 1.8 degrees Fahrenheit to 1 degree Celsius. Okay, so that's the first part. In the next part, we need to adjust for the different freezing points. So remember, the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. So we need to take that difference into account. All right, so let's say that we're trying to calculate the temperature in Fahrenheit. And we're given a temperature in Celsius. What we have to do to convert Celsius to Fahrenheit, we're going to multiply the Celsius temperature by 1.8. So we're taking into account the difference in scales. And then we're also going to add 32, and that adjusts the freezing point of water. All right, so actually let's go back to our thermometers. So again, remember we had to take into account the size of the degrees. So we had the 1.8 scale that we were multiplying by the temperature in Celsius. And then we also had to take into account the difference in freezing points for water. So we just had to add 32 in order to get to our temperature in Fahrenheit. Okay. Now what if we have to go in the opposite direction? What if we're going from Fahrenheit to Celsius? Well, this is an algebraic equation, so we can just isolate the temperature in Celsius by rearranging and moving things around. So the first thing to do is subtract both sides, or subtract 32 on both sides. So that's this step shown here. And we end up with the temperature in Fahrenheit minus 32 is equal to 1.8 times the temperature in Celsius. So then the next step is to divide both sides by 1.8. And then we end up with this equation, where the temperature in Fahrenheit minus 32 all divided by 1.8 is equal to the temperature in Celsius. So these two equations are what we'll use to convert between Fahrenheit and Celsius, depending on which one we're trying to get to. So those might be useful to write down. And let's do a practice problem so that we can get used to this equation. So in this example, a person with hypothermia has a body temperature of 34.8 degrees Celsius. What is that temperature in degrees Fahrenheit? Now, typically when we're solving a problem like this, we can write out what we're given, what we need, and how to connect those two. So what we're given in the problem is that we have a temperature reading of 34.8 degrees Celsius. And then we need to convert that to a temperature in degrees Fahrenheit. So to go from our given value to what we need, we're going to use the temperature equation that we solved for earlier. All right, so all we really have to do here is plug in the temperature in Celsius. So if you want to pause the video and try that on your own, feel free, and when you unpause the video, we'll go over the problem. Okay, so let's figure out what our temperature in Fahrenheit is. So we have 1.8, and then we're going to plug in the temperature in Celsius, which is 34.8, and then we're going to add 32. Okay, so I'm going to plug this into my calculator. So we've got, let's see, 1.8 times 34.8, and I'm going to hit enter. Okay, so that's 62.64. And then we're going to add 32. When we add 32, we get 94.64. Okay, and that's degrees Fahrenheit. So notice that I solved this problem in multiple steps. You don't have to solve everything at once, and in fact, sometimes your calculator might end up assuming that your order of operations is different than what it actually is. So I go step by step just to prevent any errors from happening. Okay, so here here's the solution slide if you need that later. But also, if you didn't get the same answer that I did, just make sure to go back and double check your work, or double check that you set everything up in your calculator correctly. And then the last measurement is time, and we said that for both the metric system and the SI system, we use seconds. Now, of course, we can turn seconds into minutes or hours or days or years, depending on how much time we're referring to. And then in lab, we'll typically use a stopwatch in order to measure the time it takes for something to happen, like a reaction, for instance. All right, so let's do a quick learning check. What are the SI units for the following? So A, we have volume, B, mass, C, length, and D, temperature. So what is the SI unit for volume? That would be the cubic meter. What about mass? So that would be the kilogram. What about length? So that would be the meter. And temperature. That would be Kelvin. All right. Now, speaking of Kelvin, we did not go over how to convert from Celsius to Kelvin, for instance. So let's actually go back and go over that conversion. Okay, so we talked about how to go from Fahrenheit to Celsius, but how do we go from Celsius to Kelvin? Now, luckily, because the degree amounts are the same between the freezing point and the boiling point, we don't have to adjust for that. What we do have to adjust for are the different freezing points. All right, so let's say we are trying to calculate the temperature in Kelvin given a temperature in Celsius. All we have to do is add 273. So we're just accounting for the difference in the freezing points. Now, what if we're trying to go in the opposite direction? What if we're given Kelvin and we want to go to Celsius? We're just going to subtract 273 from the temperature in Kelvin, and that will give us the temperature in Celsius. All right. So I think we're going to end the lecture here today. And if you have any questions, remember you can always set up an office hour with me using the Calendly website. And next time, we're going to continue chapter 2.